So my plan for today is to going over the review sheet, and most likely we won't be able to finish it. So we'll keep doing the review on Thursday, and your exam will be on Friday. Any question from anyone before we start? Any question, comments? Nothing. Okay. So we have we finished we didn't finish 2.3 in our last class, and with the sub we did 2.4. So we have little bit information left from 2.3 and 2.4, but we are going to cover everything today. And Thursday, your exam will be on Friday. And then next week we have 3 days, Tuesday, Thursday, and Friday. We are going to do review for the final exam. And then your final exam is on Wednesday. Next week, Wednesday on 17th, 8 a.m. in the morning. Oh, and all the homework and quizzes, the last day to do any of them is 8th or 7th, I forgot. And after that, my math lab, I will not open my math lab for anyone, okay? So whatever you are missing, make sure you do everything before the 7th or 8th, I forgot. Okay? So, this review sheet also posted on Brightspace. So we start with limits. Depending on what type of limit we have, we use different methods to evaluate our limit. So when you find the limit at a point, if step 1 is always same, substitute the limiting value into the function. And then based on the outcome, you take different steps. Once you substitute, if you get a number over number, then you stop, and that's your answer. But if you get something like 0 over 0, then you have to modify your function based on what type of function you have. Most of the time, you just factor cancel and then resubstitute the limiting value again. And then you have number over 0. If you have a number over 0, then if you have number over 0, then that means you're dealing with vertical asymptote. For vertical asymptote, it take 2 number and then substitute into the limiting value. If the left number equals right number, then that's our limit. If both numbers are different, then the limit doesn't exist. For vertical asymptote, we don't get a number as our limit. We're supposed to get infinity. So these are the 3 types of limit we have at a point. So we are going to do a few examples on this. For example, the first one, we are taking the limit x goes to 1 of the function x squared plus 2x minus 3 divided by x squared minus 1. So in step 1, we are going to substitute the limiting value and see what type of scenario we are dealing with. So first we substitute, we get 1 square plus 2 times 1 minus 3 divided by 1 minus 1. So on the top we have 1 plus 2 minus 3. On the bottom we have 0. So we have 0 over 0. 0 over 0. 0 over 0. 0 over 0 means the second scenario. So in this scenario, you have to modify the function first and then resubstitute. So on modify, our goal is to factor and cancel if possible. So the numerator is factorable directly. So is the denominator. In the numerator, you're looking for two numbers, multiply to 3, combine to 2. So we get plus 3 minus 1. 3 times negative 1 is negative 3. 3 minus 1 is 2. The denominator is difference of perfect squares. So for difference of perfect squares, you add and subtract their bases. So you get x plus 1 and x minus 1. And then you see they both have x minus in common. So we cancel and we get x plus 3 over x plus 1. And then we okay, Johnny, no problem. Thanks for letting me know. Then we resubstitute our limiting value into the new modified function. And we get 1 plus 3 over 1 plus 1. So that gives us 4/2, which is 2. So our limit is not 0 over 0. Our limit is not undefined. It's 2. And whatever we canceled, that canceled term gives us also something. From the canceled term, we get removable discontinuity. Discontinuity. To get the removable discontinuity, it gives us a hole in this scenario. So we set the cancel term equals to 0 and we solve for x. So our hole is at x value 1 and y value 2. So our y is x plus 3, x plus 1. That gives us 4/2, which is 2. Removable discontinuity. Removable discontinuity leaves us a hole, and the limit we get by substituting into the modified function. In the next example, we do the same thing. Step 1, you substitute the limiting value and see what type of scenario you have. So limit x goes to 5, 7 minus 2 times 5, 5 minus 5. We get 7 minus 10 over 0, negative 3 over 0. So it's not 0 over 0, it's a number over 0. A number over 0 means you're dealing with vertical asymptote. Vertical asymptote, it means your limit has 3 choices. Either it's positive infinity, or it's negative infinity, or the limit doesn't exist. There are 3 choices we have for this scenario. So how do you know which one is this? We look at one-sided limit. So first we look at the left side limit. We go to the limit x goes to 5 from the left side of this function. 7 minus 2x over x minus 5. And then you pick a number from 5 on the left side. So if this is 5, this is 4, and this is 6, you have to pick a number that is very close to 5, but between 4 and 5. For example, 4.99. So you take x equals 4.99. And then you substitute 7 minus 2 times 4.99 or 4.9, whatever. And then 4.99 minus 5. So, in this scenario, so 4.99 times 2. 9 times 2 is 8. You left with 1. 9 times 2 is 8. Plus 1 is 9. 4 times 2 is 8. Plus 1 is 9. So it's 7 minus 9.98. And the denominator is minus. So we have numerator minus, denominator minus. So we have positive infinity. So left side, on the left side of the 5 is going to positive infinity. Now we need to know how the right side is going. So you go to 5 from the right side of this function. 7 minus 2x, x minus 5. And we do the same thing here. You pick a number on the right side. So for example, here we have 5.01. So x value is 5.01. 5.01. So we get 7 minus 2 times 5.01 divided by 5.01 minus 5. So this time we get 7 minus 5 times 2 is 10.02. And then 5.01 minus 5, we have positive here. So we have negative on the top, positive on the bottom. Our limit is negative infinity. So the left side is going to positive infinity, but the right side is going to the negative infinity. That means the exact limit s goes to 5 of this function. The left is positive, the right is negative. So exactly at this point, the limit doesn't exist, because this is what is happening. When x is 5, we have a vertical asymptote. The left is going up, the right is going down. So at 5, there is no limit. The limit doesn't exist. Any question? No question from anyone? The next question is find VA means vertical asymptote. In your last class with the sub, did you guys learn about vertical asymptote? What is vertical asymptote? Did the sub go over that with you? No. Okay, so vertical asymptote is a line that breaks a graph into pieces. For example, here when x is 5, our graph break into 2 pieces. So x equals to 5 is a vertical asymptote. And how do you know it's a vertical asymptote? Because you observe the denominator. The simplified denominator, if we set it equals to 0, then we get the vertical asymptote. So here we have 7 minus 2x over x minus 5. We cannot simplify this expression. So when we cannot simplify, it take the denominator, set the denominator equals to 0, and that gives us the vertical asymptote. That's why when you have a number on the top but is 0 on the bottom, that 0 tells us that we have a vertical asymptote to deal. Here we are dealing with a vertical asymptote. Means it's just not a random point. It's a point where our graph divides into pieces. Similarly, here on the right page, we have nothing to simplify. So if you look at the denominator tells us where our graph breaks into pieces. So here we have two pieces. When you take the first piece, set it equals to 0, and when you take the second piece, set it equals to 0, these are the vertical asymptote. These are the points we get for vertical asymptote. So x equals 2 and x equals 3. It means our graph breaks into two pieces. When x is 2 and when x is 3, there is a vertical line that divides our graph into different pieces. So I'm not sure about how. Actually, let me show you the graph so you can see what's happening. X minus 1. Let me take a graph for you so you have an idea. Okay, so this is the graph of this picture. This is the picture of this graph, what I'm saying. If you look at the graph, when x is 2, our graph breaks into two pieces. And when x is 3, here asymptote. Yeah. This is another vertical asymptote. So how do you know them? How do you know there's a two vertical asymptote? You look at the denominator. You take the first denominator, x minus 2, set it equals to 0. That gives us the first vertical asymptote. Then you take the second piece on the denominator, x minus 3. You set it equals to 0. You get your second vertical asymptote. Vertical asymptote is the vertical line that you cannot cross. So your graph has to be on one side of the vertical asymptote. So on the either side of the vertical asymptote actually. So x equals 2 has a left part on the left. So for example here, this is x equals 2, and let's say this is x equals 3. So one piece is here, one piece is here, and then another piece is here. So our graph divides into three pieces with two vertical asymptotes. Okay. Notation. Let me do stuff of this. Will the exam include calculator? Yes. This exam will have also calculator part. So have a calculator that you know how to use. Okay, so here, if you have no idea about vertical asymptote, what is this? We look at the limit, and then the limit tells us whether are you dealing in vertical asymptote or just normal limit problem. So first step is substitute the limiting value and see what type of scenario we have. So our limiting value is 2. We substitute 2 into every x you see into the function. So limit x goes to 2 of x minus 1 square, and then x minus 2, x minus 3. First step is substitute, so you get 2 minus 1 square divided by 2 minus 2, 2 minus 3. Now 2 minus 1 is 1, and this is 0. 0 times anything is 0. So you see, we have a number over 0. Anytime you have a number over 0, it means this is a vertical asymptote. So vertical asymptote means your solution, the limit, will be either positive infinity or negative infinity or dne. Like in the last example, it was dne because the left side limit and the right side limit wasn't the same number, wasn't the same symbol. So here we are going to do the same thing. Since we know it's vertical asymptote, so we need to get one number very close to 2 from the left side, and then another number very close to 2 from the right side, and you have to look at the symbol. So we first start with the left side. If you take a number, then let's say 2. So we have 2 on the left, 1.99. So our x is 1.99, and we substitute this 1.99 into our function, and we observe the sign, what sign it gives us. So 1.99 minus 1 square, 1.99 minus 2, 1.99 minus 3. Now the numerator, the square, so it's always positive. Now between 1.99 and 2, this is negative because 2 is smaller, so 2 is bigger. And here 3 is bigger, so this is also negative. So you get negative times negative, that turns into positive. So here we have positive infinity. So left side is going to the positive side, positive infinity. Now we need to look at the right side. So limit x goes to 2, x goes to 2 from the right side of this function. Now for the right side, we have a number here, let's say 2.01. So x value is 2.01. So we are going to substitute 2.01 minus 1 square, then 2.01 minus 2, 2.01 minus 2. Again, numerator is always positive because it's square. And then here 2.01 is bigger, so this is positive. But here 3 is bigger and this is negative. So plus times minus gives you a minus here. So our right side is negative infinity. Our left side is telling us that our graph is going to positive infinity, and our right side is telling us we are going to the negative infinity. That means exactly at 2, limit x goes to 2, exactly at 2, the limit doesn't exist because the left side limit and the right side limit are not same. If both symbols are same, then our limit will be that. But if you have two different symbols, then the limit doesn't exist. So these two scenarios are particle asymptote problem. And for particle asymptote problem, you just substitute some numbers. One from left, one from right. Any question? Then we have one-sided limit for piecewise function. So piecewise function, it means we have different pieces of functions on the same plane. And based on each piece, you look at the limit in the... Huh? What did you say? Did you guys say anything? I didn't hear you. So for one-sided limit, what we do is you look at the same thing. You look at the left side limit and you look at right side limit. To look at the left side limit, you take the left function, is substituted into the left function, and you observe the y value. Then to look at the right side limit, you take the right function and you look at the y value. If the left limit and the right limit are the same number, then the exact limit is that number. But if the left limit and the right limit are not same, then the exact limit doesn't exist. For example, here, we have two functions. The first function is y equals 2 minus x when x is less than 1. So if this is x equals 1, when x is less than or equal to 1, if function is y equals 2 minus x, and when x is bigger than 1, then there is another function you have y equals half of x plus 1. So two functions on the same plane, and they want us to find what's the limit at 1, means what's the y value it's supposed to get for x equals to 1. So since the piecewise function, you need to look at the limit, both limits. So you look at the left limit. Limit x is going to 1 on the left side of this function. Now on the left side of this function, this is the y we have. So you take this number, not this number, you take this function, the left function, and you substitute 1 into the function to see the y value. So you get 2 minus 1, which is 1. So the left side is telling you that when x is 1 or less than 1, your y value is 1. And then you look at the right limit. X is going to 1 from the right side. Now on the right side of the 1, this is your function you have. So you go to, this is your right side. You take this function, half of x plus 1, and you substitute x with 1. So you get 1 half plus 1, which is 1.5. Now the left side is telling you your y value is 1, but the right side is telling you your y value is 1 half. Since you have two different y values for the same x value 1, that means the exact limit exactly at 1 of this function doesn't exist because of this problem. The left and the right, they are not the same number. Okay? Any question? The next one is same. It says find the limit at 2. Huh? In order to find the limit at 2, since this is a piecewise function, that means you need to look at the left limit and you need to look at the right limit. And then you find out if these two numbers are same, then the limit exists and that's the limit. But if both of them give you two different numbers, then the limit doesn't exist. So, same scenario. When x is 2, you're here. So before 2, when x is smaller than 2, our function is y equals x squared minus 3. And after 2, your function is y equals, you can cancel this and you're left with 1 over x minus 3. And then you look at the y value for both scenario. So limit x goes to 2 from the left side. This is our left function, left of 2. So you write this function, x squared minus 3. And you substitute x with the limiting value. You get 2 squared minus 3, 4 minus 3, you get 1. Then you look at the right side limit. This is you. Then this is 2, right of 2. So you look at the limit, x goes to 2 from the right side. And this time your function is 1 over x minus 3. So we do the same thing, is substitute the limiting value. So you get 1 over 2 minus 3, which is 1 over negative 1, which is negative 1. And again, we are facing the same problem. The left number is telling us it's 1, but the right limit is telling us it's negative 1. So the exact limit exactly at 2 of this piecewise function, it cannot exist because the left and right, they are not same. In order for the limit to exist, we have to have the same number on the left side and on the right side of the limiting value. Okay? Any question? Are you guys understanding what I'm doing?
Oh,
Huh?
John,
If you don't understand, please let me know. Otherwise, how do I know?
I'm kind
And
of
wait,
lost.
so tell me where, like, which part?
Like the whole thing.
Whole thing doesn't make sense. Did you
Can you like
understand?
do a question?
So what I'm doing the question. These are the questions I'm doing.
Like, can you do another one?
Hmm, okay. So let's say we have a function f of x equals, let's say, x squared when x is less than 0 and 2x when x is bigger than or equal 0. Okay? So this is called piecewise function because we have different pieces of the function on the same plane. So before x equals 0, if this is x equals 0, before x equals 0, we have a function y equals x squared, which is a parabola. Now after x equals 0, we have a function y equals 2x, which is a line. So if you do want to draw, the graph will be something like this. This is x equals 0. Before that, we have x squared, and after that, we have 2x. So this is a piecewise function. Now they're asking, hey, find the limit when x is 0 of this piecewise function. What's the limit of, limit means y value. What's the y value when you go x equals to 0? So when you go x equals to 0, you have to look at from the left side, and you also have to look at from the right side of 0, and you have to see what's the y value you get when you go from the left side and when you go to 0 from the right side. That's the main thing here. What's the y value you get when you walk from the left and when you walk from the right? So that's why I need to look at both direction. First, you look at the left direction. If you walk from the left direction, what's the y value you get? So you take limit x goes to 0 from the left side. Now 0 of left of the 0. Left of 0 is this part. This is our left function, left of 0. So when you look at the y value of the left of 0 function, you need to get the function that is on the left side of the 0. So what you do is substitute the limiting value into the left function and you get the y value. So this is 0 squared, which is 0. So the left function tells us our y value is 0 when you get close to 0 from the left side. Then you walk from your right side. Means you look at your right function, right of 0. This is your right of 0. So limit x goes to 0 from the right side of the 0. Now, right side of the 0 has a function y equals 2x. So you need to use the right side of the 0 function and substitute your limiting value into the right function. So you get 2 times 0 and then side 0. Now what do you observe? When you walk from the left, your y value is 0. When you walk from the right, your y value is still 0. So both the left and the right gives you the same y value 0. So the question they ask us, what's the y value of this function when you walk from the left and from the right? The answer is 0 because both of the numbers are 0. In the last two examples, the left function gives us one number, the right function gives us another y value. The two y value we had were not same, so there wasn't any y value exist as a limit when you are exactly at 2. But here the limit does exist. The limit exists because the left function gives us the y value 0, the right function gives us the y value 0. Both functions gives you the y value 0. That means exactly at x value 0, our y value is the same number as the left and right limit, which is 0. Now, what do you think? Are you guys still confused? So what you're solving for? You're solving for the y value. What's the y value of this function when you look at the x value given to you? Is it clear? Or are you guys still confused? Let's do one more example. Let's say we have another function. F of x equals, let's say, x cubed minus 1 when x is smaller
Oh,
than
that's fixed.
when x is smaller than 1, and let's say you have x to the 4 plus 1 when x is bigger than or equal 1. They're asking you to find the limit when x is 1. What's the y value is supposed to get for x is 1? So if you observe, first of all, if you observe, look at the limiting, look at the domain. Your domain breaks into two pieces. One is before 1 and one is after 1. Before 1, you have one function. So this is the left of 1. And after 1, there is another function. So this one is the right of 1. But what they're asking exactly at 1, what is your limiting value? Huh? What did you say? So to get the limit for x equals 1, since this is a piecewise function, so you cannot just randomly pick one of them. You have to look at the y value for both function. When x is 1, what's the y value the left function gives us? When x value is 1, what's the right function gives us? So you have to look at both left of one function and the right of one function. So first, you look at the left of 1. X goes to 1 from the left side. On the left side, this is the function you have. Left of the x value 1. X cubed minus 1. So you need to know the y value. How do you find the y value? You substitute the limiting value here. So you get 1 cubed minus 1, which is 0. So the left side is telling you when you are going to go 1 from the left side, your y value is going to 0. Okay? This is what information you have here. Then you look at the right limit. Limit x goes to 1 from the right side. The right side of the 1 is the second function, the lower function. So you take this lower function and you substitute this 1 into the function to look at the y value. So you get 1 to the 4 plus 1, which is 1 plus 1, which is 2. So this one is telling you when you are going to 1 from your right side, your y value is actually going to 2. The previous one said when you are going to x from your left side, your y value is 0. And this one is telling you when you are going to 1 from your right side, your y value is 2. So you see, there are two different y values you get. The left y value and the right y value are not the same number. One side is telling you when x is 1, your y value is going to 0, something like this. And the right one is telling you your y value is going to 2, something like this. So there are two different y values. One is 0 and one is 2. That's why the question they ask here, exactly at one of this function, what should be your limit? We say, well, the limit doesn't exist. The limit doesn't exist because the left limit and the right limit are not same. Left hand limit are not same as the right hand limit. Okay, that's why the limit doesn't exist. Left hand limit and right hand limit, they are not same. Is it clear now? Any question from anyone? Okay, then the next one is infinite limit. Infinite limit means when you are looking at the x value from the left side and from the right side, how the y value is going in general at the end, toward the end. For example, if you look at square graph, the left side, when x is going to the left, negative infinity, your y is going to positive infinity. Same thing when you're going to the right side, when x is going to positive infinity, how the y is moving, y is going to positive infinity. So limit at infinity means when x is too big or too small, what's the y value we get? So the left-hand limit, the right-hand limit are the same. If the left-hand limit and the right-hand limit same, then the exact limit exists and it's the same number. For example, here, if you look at the left page, the left-hand limit was 0, left-hand limit, and the right-hand limit was also 0. If you have the same y value for both left side and the right side, then exactly at that limiting value, your y value exists or your limit exists, and the limit is the same number as your left limit and the right limit. When the left hand limit and the right hand limit gives you the same y value, then exactly at that x value, the limit exists and it's the same y value as the left and the right limit. But if the left hand limit and right hand limit are two different numbers, then exactly at that limiting value, the y value doesn't exist because we have two different limits. Y limit tells us the y value, okay? Okay, so limit at infinity. So how do we know what's the y value? What x is positive infinity or negative infinity? We use the three rules for horizontal asymptote. So I believe you solve point over horizontal asymptote. Let me just go over briefly. Horizontal asymptote means what is your horizontal boundary? What's the number you go when you go horizontally? Do you have any boundary in your graph? So horizontal asymptote. Horizontal asymptote. Horizontal asymptote depends on your types of function. We have three types of functions. Y equals, let's say, x big over x small means we have higher power on the numerator, or we have y equals x small over x big. Either the numerator is smaller power than the denominator, or x same number on the top and on the denominator. Okay. So depending on the scenario, you get three different horizontal asymptotes. When the numerator is big, there is no horizontal asymptote. No horizontal asymptote, and the limit you have to calculate your limit. Limit needs to be calculated. Okay. There is no horizontal asymptote, means there is no problem. The graph is going on forever, either upward or it's going on forever downward. There is no asymptote horizontally. So what's the y value? You have to find. Either the answer will be positive infinity or the answer will be negative infinity. You have to figure that out. In the second scenario, anytime you have a denominator is big, your horizontal asymptote is y equals 0. Always, always, always. It doesn't matter what number you have, as long as you have the highest degree on the denominator, a horizontal asymptote is y equals 0. And same thing, you limit x goes to either positive infinity or negative infinity, it doesn't matter. Your limit will always be 0. Means, for example, you have a graph like this. This is what it means. When you go x equals to negative infinity, your y value is going to 0. And when you go to x equals positive infinity, your y value is going to 0. So y is 0 on the left and on the right. So your limit is also 0. And then the last scenario, you have the same number on both numerator and denominator. And if you have some type of coefficient, then your horizontal asymptote is y equals their coefficients. So the limit, whether you go to positive infinity or you go to negative infinity, it doesn't matter. Your limit and the horizontal asymptote are the same number. It's the coefficients. Whatever coefficients you have in front of numerator and denominator, combine them, that's your limit. So depending on what type of scenario you have three different limits or three different asymptotes. Numerator big means no horizontal asymptote, and your limit, you need to find it. There is no fixed limit. You need to find it. But if your denominator is big, your horizontal asymptote is always y equals 0. So your limit is always 0. Means cy value is always be 0. Cy equals 0, y equals 0. And then if you have the same highest degree on the numerator and denominator, then your coefficients is your limit and also your horizontal asymptote. So you do have to memorize these three rules. Let's do some example. It says find the horizontal asymptote and also the limit. To find the horizontal asymptote, all you have to do is look at the highest numerator and highest denominator. The limit x goes to infinity. The highest term, both the numerator and denominator are these. So 2x squared, 3x squared. We have the same x squared and x squared, they cancel out. So our limit is 2 over 3. And this is also your horizontal asymptote. Horizontal asymptote is y equals 2 over 3. Your asymptote and your limit are the same number. The next one is same. Limit x is going to negative infinity, and you just have to look at the highest degree on the top. Highest degree on the top is 2x, and highest degree on the bottom is this one, 3x squared. So x and x squared cancel out. If denominator is bigger, anytime the denominator is bigger, we don't care about anything else. The answer is automatically 0. So your horizontal asymptote is y equals 0. Okay. Denominator bigger means it's always 0. You don't care whether you're going to positive infinity or negative infinity, doesn't matter. The answer is 0. X is going to infinity. Your highest degree is 2x cubed on the numerator, and your highest degree is 3x squared on the denominator. So you write 2x cubed over 3x squared. Now, obviously, numerator is big. When the numerator is big, your horizontal asymptote, it automatically doesn't exist. Okay? When the numerator is bigger, there is no problem with the function. So your horizontal asymptote doesn't exist. However, you need to find your limit. You need to calculate the limit. So what you do, you cancel x squared and x cubed. You get x on the top. So you write limit x goes to infinity 2x over 3. And then you substitute your limiting value here. So you get 2 times infinity over 3. Infinity times any number is infinity itself. So your limit is infinity, means when x is going to the positive infinity, your y is going up. So x is going to positive infinity, y is also going positive infinity. This is what it means. The limit is infinity, and asymptote doesn't exist. Asymptote means it's a line, a boundary. So this function doesn't have any boundary. So there is no boundary. So your limit means the y value is getting bigger and bigger. Similarly, the next one, the highest entry is negative 2x cubed on the top, and the bottom 3x squared. So you write limit x goes to negative infinity of negative 2x cubed over 3x squared. Numerator is big, so automatically there is no horizontal asymptote. There is no boundary. However, you need to calculate your limit. So you cancel x cubed and x squared, you get x on the top. So you write limit x goes to negative infinity of negative 2x over 3. And then you substitute. Your limit is negative infinity, so you substitute here. You get negative 2 times negative infinity divided by 3. Negative and negative turn into positive. So you get positive infinity. So basically you have 2 times infinity over 3, but infinity times any number is infinity. So your answer is positive infinity. What does it mean? It means when x is going to negative infinity, if y is going to positive infinity. So something like this. If x is going to go smaller and smaller, but if y is still getting bigger and bigger and bigger. Any question? No question from anyone? So these are all the limits. Limit at infinity, limit at a point, limit for piecewise functions, limit for vertical asymptote, and limit for infinity by infinity case. In the exam, you're going to have all of these. So any question from anyone? No question. Then we have vertical asymptote and the renewable discontinuity. So again, to find the vertical asymptote, first you need to modify your function if possible. If not possible, then it's fine. But if it's possible, then you need to modify the function and then take the modified denominator, set it equals to 0. If it's not simplificable, then you take the original denominator, set it equals to 0, you get your vertical asymptote. For renewable singularity, renewable discontinuity, whatever you cancel, you set that equals to 0. Huh? What did you say? Did you guys say something? Okay, so for example here, it says this function has a line and a hole. What is that line and where is that hole? So hole, remember, hole means cancelled term equals to 0 and you're solving for x. So basically they are saying, hey, simplify this. So we have f of x equals x squared minus 6x minus 7 over x plus 1. So first we need to simplify. And it is simplificable because we can vector the top. Two numbers multiplied to -7 and combined to -6 is -7 and +1. So we cancel the +1 and we get f of x equals x minus 7. This is the line they were talking about. It's a line. And now the whole, we get it from the cancelled term. So we set x plus 1 equals 0. We get x equals -1. But whole is a point. So it has both x and y value. We only found the x value -1. So to get the y value, we substitute into the modified equation. Y is x minus 7. So we get -1 minus 7. That gives us -8. So our whole is happening at x equals -1, y equals -8. Now for the next one, you need to find all the information: domain, vertical asymptote, horizontal asymptote, whole. So to find the domain, you just take the original denominator, set it equals to 0, solve for x. So original denominator is x squared plus 2x minus 8. You set it equals to 0. And then you factor x minus x plus 4, x minus 2. Two numbers multiplied to -8 combined to +2. So you get x plus 4 equals 0, x minus 2 equals 0. So x equals -4, x equals 2. Now you need to omit those from the number line. So domain is everything else besides these two. Actually, it should be not equals to 0 because denominator cannot be 0. So x can be everything else, but it cannot be -2, -4, and +2. So -infinity to +infinity, you can take out any number to replace it x with, but you cannot take -4 and you cannot take the +2. So domain is the first interval, -infinity to -4. Since you cannot use -4, so it's parentheses. The next interval is from -4 to 2. And both of them you cannot use because they will make the denominator 0. And then lastly, the last one, every number bigger than 2. So from 2 to infinity. But you cannot take 2 because that makes the denominator 0. So it's parentheses. So domain is everything else except whatever makes the denominator 0. The can use the number means bracket, cannot use the number means parentheses. When x is -4, the denominator is 0. Can you have 0 on the denominator? We cannot. So can you use -4? We cannot. So it has to be parentheses. Same thing for 2. When x is 2, the denominator is 0. Can you have 0 on the denominator? We cannot. So can you use 2 for x? we cannot. Since we cannot, so it's parentheses. Clear, Jalen? So once you know your domain, then for everything else, you need to modify your function. So simplify. On the numerator, we have x plus 3 and x plus 4 after factoring. On the denominator, we have x minus x plus 4 and x minus 2 after factoring. So, Jolene, did you hear my explanation? Did you guys hear it when I said yes? Okay. So, x plus 4 cancel out. We get f of x is x plus 3 over x minus 2. Now, if you set the top equals 0, you get x-intercept. If you set the bottom equals to 0, you get vertical asymptote. And if you set x plus 4 equals 0, you get removable discontinuity. Okay, so everything you do gives you something. The next one is asking for removable discontinuity, means the cancel term. So x plus 4 equals 0 gives you x equals -4. And then to get the y, it's -4 plus 3, -4 minus 2. So -1 minus 6, which is 1, 6. So you have a hole at -4, positive 1, 6. The next one is asking for the vertical asymptote, means denominator. So denominator is x minus 2. You set x minus 2 equals 0. You get x equals 2. That's your vertical asymptote. Means this is the line that breaks your graph into two pieces. Horizontal asymptote. So we have y equals x plus 3 and x minus 2. The highest power on the top and bottom, we have horizontal asymptote. Y equals x over x. They both have coefficient 1 and 1. So the answer is 1. So y equals 1 is your horizontal asymptote because you have the same power. So they cancel out. And then in our next class, try bringing a calculator to find the vertical asymptote. To find the vertical asymptote, you say that the numerator equals to 0, solve for x. You said the denominator equals to 0, solve for x. And then if you see any number common in both numerator and denominator, you cancel them. And then the remaining denominator will give you the vertical asymptote. Okay, so you just need to know how to solve your equation in a calculator. And we are going to do a few of these. And then you have continuity. And then that's it about 3.4 and 2.3 and 2.4. And then we covered 2.7 and 2.8, 2.10. We already covered that. Okay. So please do your homework on 2.3, 2.4. Whatever we don't understand, we can go over that in our next class along with the review sheet. Okay. So we are done with the syllabus. We basically did everything. And just in the next class, we are going to do a little bit continuity, which you already know. It's based on the limit we said. In order for a function to be continuous, the left limit and the right limit have to be the same number. If it's not the same number, then the function is not continuous because the limit doesn't exist. Okay? Oh, the left limit, right limit, and the y value, all three things have to be same in order for a function to be continuous. So we are going to do these examples in our next class, and then we'll be done. Any question from anyone before we leave? Any question, comments? In the final, I don't know how many will be, but at least 2 to 3. And from this review sheet, there'll be many questions in the final exam. And in your exam, every question you see in every part, there will be some question. Okay, thank you, Jolene. I didn't take the attendance today. No. To see you guys. Oh man. See you guys on Thursday. Bye everyone. Thank you. Don't forget to do your homework. Thank you, Alexandra. Thank you, Ellen, Amir. Have a good rest of the day. And don't forget to study.